So we can have more examples for the reaction of Grignard reagent with our carbonyl compounds, but you can have that in practice. So how do we plan a Grignard synthesis? So to plan a Grignard synthesis, we have first to synthesize. For example, you have your target compound, no? You have your alcohol here, and you can think of how do we plan to prepare this one using a Grignard reagent. So first one, of course, is the retrosynthetic analysis. You can break this one here and here, and your starting material will be this, and your Grignard reagent, MgBr, this one, and you get your kani. Of course, before this one is your ketone, diba? And so you have this. And then you do the synthesis. You start with this and your ketone, methyl, and of course, your first step is your the use of a solvent, just this reaction. The second step is the protonation reaction. Second method is the retrosynthetic approach again, but you can have this one is your to disconnect in this part. No, if this is your projected product, you can disconnect in this part, and this one will become your Grignard reagent, like MgBr, and this one is your ketone you have here. So you can start with this reagent, methyl MgBr, magnesium bromide, and your ketone, your methyl phenylketone. And the presence of this, you actually get your alcohol here. Another method is kaning duha. You can do the disconnection here, and you just have to use 2 moles of your methyl magnesium bromide. So you do 2 moles of that. So the synthesis first is you start with an ester like this one. You can have this one. If you use 2 moles of your Grignard reagent, actually you can start with an ester. No? So you have your ester and your solvent and your acid, source of acid to acidify from your O alkyl MgBr. So just some restrictions on the use of Grignard reagents. Grignard reagents are useful noctiphiles, but they're also very strong bases. So being a base, it's not possible to prepare a Grignard reagent from a compound that contains any hydrogen more acidic than the hydrogen atoms of an alkane or alkene. So since it's also being a noctiphile, but a noctiphile seeks a positive center, a base is the one that usually obstructs a proton. No? So a Grignard reagent cannot be prepared from a compound containing an OH, an NH group, an SH, or CO2 or SO3 group. Yan naman, by itself, no, basta mo react siya to deprotonate this group here. I-obstruct niya ang hydrogen. So it's not pwede to use a Grignard reagent that also in the compound itself na siya aning mga group. Since Grignard reagents are powerful noctiphiles, we cannot prepare a Grignard reagent from any organic halide that contains carbonyl, epoxy, nitro, or cyano. So being a noctiphile, basin o-form na siya gihapon og attack, noctiphilic attack by sa iyarahang kaugalingon, no, with the substrate itself. So dili pwede nga naapoy any reagent from any organic halide that contains a carbonyl compound. So basin ang instead of the alkyl, no, from an organic halide ang i-attack, it's the carbonyl hinoon or the epoxy or the nitro. So much better if we use an alkyl halide, no, for our reagent. Dapat wala siya any other groups. Because otherwise, possibly put si Grignard reagent that can attack this kind of reagent, this kind of functional groups. Grignard reagents cannot be prepared in the presence of the following groups, but they will react with them. Ang wala naging balik sa this group, so OH, NH2, SO3H, so on. For the use of lithium reagents, you can have your similar way. You can have your aldehyde. Also, you have your organolithium reagent. The same with Grignard reagent. No? Instead of MgX, like MgBr, no? You use your alkyl is attached to lithium instead. So you have your organolithium reagent. And similar way that your alkyl can attack your organic compounds, the carbon-carbon, inanapod ang process for an alkyl from organolithium reagent can attract an aldehyde. So here will be our source of electrons. So to be our nucleophile can attack the positive carbon here. And once it attack, the electrons gikan sa ilang duha will be directed towards ng oxygen to form O-. So it will be paired with lithium being negatively charged. So you get your lithium alkoxide here. And further acidification of your O- here, you get your alcohol in the process. So same process shall with Grignard reagent. Organolithium reagents have the advantage of being somewhat more reactive than Grignard reagents, although they are more difficult to prepare and handle. Pareha yung reaction. The only downside, no, it's very reactive and difficult to handle. Say difficult to handle, it can be dangerous, and that's why we have to handle or to do the reaction with care. You can also use sodium alkanides. The preparation of sodium alkanides, you have your you have this kind of reaction before. You use your sodium amide to eliminate the hydrogen. Okay, and you get your source, your NH2 will be your source of a base to abstract this one. So you get your NH3. And what happened is that you get your alkynide. The carbon with triple bond R here will get the electrons and a negatively charged. So for that, it can be also our source of nucleophile to attack your carbonyl carbon. So once you have that one, your carbonyl carbon, sodium alkynide, no, can be used as kaning alkynide can be used as our nucleophile to attack your carbonyl carbon. So we use the electrons here to attack the carbon here. Pag attack niya, you can actually have your O-, so it can be paired with sodium being negatively charged. And further, we can acidify with hydronium ion, so any acid to get your alcohol. But this case, you get your alkene in the structure of your alcohol. Sometimes we will be using protecting groups. So protecting groups, how would the protecting groups be? So for example, you have your 1, 2, 3, 4, 1, 2, 3, 4, you have your OH, and you get your 1, 2, 3, 4. Okay, instead of iodine, you have your OH here. This group will become your protecting group. So in the retrosynthetic approach, if you want to prepare rather this one, you want to prepare 1, 2, 3, 2, 3, 4, and the 5 is 1, 2, 3, 4. You have C and OH, the process. Okay, 1, 2. So in the retrosynthetic approach, you can break this one, disconnect this one, no, to form your kaninga OH with MgBr, and then you get your convert this one to an aldehyde, zero bond O, no, and you have your not aldehyde, a ketone rather, zero bond O. What I mean is a carbonyl, organic carbonyl compounds, no. And for your MgBr, can actually prepare this alkyl Grignard reagent rather from bromide. So you can have this one, the carbon Br bond from this. So this one can be prepared from this one. However, the downside, no, we have already mentioned kaganina, your Mg ethoxide, kani, Mg, rather, sorry, ethoxide, Mg in the presence of your diethyl ether, what happened is that this Mg, even if we have your MgBr, no, 1, 2, 3, 4, so this one will be used to form a bond. You have your MgBr, okay? What happened is that here is a strong nucleophile, or yes, this is a strong nucleophile, but this can also be a base, in which case, kung nakay OH in its group, it can actually deprotonate this OH here. And actually what you get is an OH here, an O minus, and what you actually get is OMGBr. And we use this one, you get your CH3 na, no? Because this one will be abstract. This one will say CH2Br, this one will abstract this one to get this. So we need to protect this OH first. So in order for this to not react with MgBr, we need to protect this OH. So another way of protecting the OH is the use of protection. So instead of OH, because you don't want this one to be deprotonated by MgBr, by the alkyl from the MgBr, what happened is that we protect this OH first before reacting with MgBr, before having the Grignard reaction to produce your MgBr. So you have a protecting group first before you proceed, because that is the primary requirement. No, when you do prepare a Grignard reagent, there should be no other atoms here that can react with your Grignard reagent. So normally dapat wala na siya, dapat wala na siya. But since if this is our desired product, kung nagi OH, digid mawala, no, we need to protect this first in order for this to not react with Grignard reagents. How do we protect? So any protecting group, and then protect this O, have some group there, replace this with another group other than hydrogen, and you have your Mg and ethoxide, and then you get your MgBr. So Mg, you get your MgBr, your Grignard reagent, and protected group. So no acidic, so other than hydrogen, any group of atoms other than hydrogen, no, para dili siya ma-react like this one. Like this one. The carbonyl carbon here, having an electrons, is a good nucleophile, but can also be a base that can abstract this one to form CH3. And you get your O minus instead. And this is where your MgBr will go instead of in this part. But this is the part where we are interested. So we don't want this one to react. And that is the reason that we need to have a protecting group. So if you have a protecting group on oxygen now, it will not react now with carbonyl carbon here. You have your C double CH2 dot dot. All this is partially negative, and this is partially positive. So once you have that one, then you can react that one with carbonyl compound. So this will be your source of CH2 dot dot, and it will attack this, and you get your OH, of course, O minus, acidify that further. You get your, for the first step, you get your OMGBr and this group here, and acidify that one, you get your OH, and you have this one here. And then the protected group have a reaction where you form this with hydrogen. That's how you process. So what do we do? So what are our usual protecting group? Our usual protecting group is the TBSCl, third butyl, silicon chloride. And you also have your imidazole. You can also have your DMF. So for instance, we use the TBSL, your third butyl silicon chloride. So you have your third butyl dimethyl silyl, third butyl dimethyl silyl chloride, Yeah. Third butyl silyl chloride. You have here TBS. Okay, so we react that one in the presence of imidazole, and this is a base. In the presence of a solvent, rather, this is a solvent, a dipolar protic solvent. So what happened is that you can protect this one, and what we get is third butyl silyl. So instead of chlorine here, now what happened is silicon, the silyl group, silyl, now it react with oxygen to get this one. And then once this oxygen is protected, we can actually do the Grignard reaction to get our Grignard reagent. So you have like your alkyl halide here, and you get your alkyl MgBr. This is now your alkyl halide, alkyl, or rather Grignard reagent with an MgBr, alkyl Grignard reagent. Alkyl and MgBr, this is your Grignard reagent. So we react with that carbonyl compound, or carbonyl compound, pseudo bond O. So this can attack this carbonyl compound. CH2 here is rich with electrons. Okay, CH2 and Mg, this is the carbon that's partially negative, and this is the partially positive. So automatically, this is the one that will be our nucleophile, and this is the one that attacks your carbonyl carbon here. Once it attacks, you get your carbon, and this one. This is the bond that's being formed between this and this. So here, this is the black, the one that is formed here. Okay, so pag ataka na niya din here, the oxygen now will bear the electrons and it become O minus. Okay, pag O minus, then it will pair with MgBr. So you get your O MgBr first. We acidify that one, and then you get your OH. The O minus will react with the proton here. Will abstract the proton here because it will be a good base. No, it's a source of electrons again with the negative charge. So it can abstract a proton, your acid, to form your OH. So you get this final product here. So once your TBSO, you get this one solid group, and then you eliminate this protecting group. This is a protecting group. Can you see? Mawala lang si chloride once it forms with oxygen. Okay, and then what happened is that you get your OH. So that is the essence of protecting. So in the end, we're done with chapter 12. Congratulations. Now basically, we're just, kanisha, protecting group is just the higher form of doing reaction with organic synthesis. But basically, you have already covered the use of Grignard reagent. So if we don't use the Grignard reagent, we can also use katong lithium, kani. If not Grignard reagent with carbonyl compounds, you can also use your organolithium reagent. Now again, the essence here, your takeaway, what is your takeaway? Is when you use your organolithium compounds, or when you use your Grignard reagent, that is your organometallic compounds, once it is being paired with a metal, your alkyl, your carbon is being paired with metal, your carbon will always be partially negative, if not fully negative. And that will be your source of electron. That will be your nucleophile to attack your carbonyl carbon to proceed with the reaction. And then, of course, once you attack from a carbonyl compound, you get your O minus. So either kung unsa nga metal iyang ma-pair, you get your O minus, and then further acidification. So whether your O is paired with lithium, if you're using the organolithium reagent, or MgBr, if you're using a Grignard reagent here, you get that one. Similar process actually will be utilized, no, and acidify further, you get your alcohol. Basically, what we have learned for today is the preparation of alcohol using organometallic compounds. So again, your organometallic compounds can be your Grignard reagent or lithium reagent. So I'm talking to myself earlier, and that ends our discussion, no, for alcohols. So also, there's also a reaction actually, no, that we haven't discussed, but also have been utilized in the previous chapter. So you remember the oxidizing agents, no? Once you have your double bond, or once you have your your oxidizing agent, actually we have covered now. Okay, so Just do not forget that there is a possible retrosynthetic approach. Retrosynthetic approach in the process in how to plan a Grignard synthesis. Now, so you study on the retrosynthetic approach once you have your, for example, target compound, target alcohol, and you want to prepare this one using, for example, this is a tertiary alcohol, right? So basically, you couldn't prepare this one, a tertiary alcohol, from a 1-degree alcohol or a 2-degree alcohol using reduction process. Sorry, you cannot prepare this alcohol from an aldehyde or a ketone using reduction, right? You can prepare this one using you can prepare this one from a ketone, like this one. You can prepare from a ketone if you have a 3-degree, alcohol. Okay, so you have a 3-degree alcohol. Here, this is your target one. You can prepare this one from a ketone and your Grignard reagent. So if 2-degree, you can prepare from an aldehyde. Okay, so sometimes dili lang mag-start sa ketone, you can also start with an ester. But an ester, maagi gyapon ka og ketone. So when you prepare a 3-degree alcohol, you have to 3-degree alcohol, you have to do the reaction using a Grignard reagent. You couldn't prepare a 3-degree alcohol for a reduction, no process. You cannot prepare, like, for example, you want to reduce because, for example, you do a reducing agent, lithium aluminum hydride, no, or sodium borohydride. Hindi siya pwede. You simply have to use a ganun. Okay. Mura to, and that ends our chapter 12. Actually, it's chapter 12. Chapter 12 is simply a continuation, no, of chapter 11. We're still talking about alcohols and how to prepare alcohols using organometallic compounds. So on Tuesday and Friday, we will have our aldehydes and ketones. And the reason why I would like to have an aldehydes and ketones, because when you go to organic chemistry, kailangan ninyo ang reactions of aldehydes and ketones. Actually, similar na siya ng mga reactions. So we will just have to proceed with aldehydes and ketones. For aromatic compounds, I would recommend, and of course, I will suggest it wouldn't be me for your next organic chemistry, which is 132. So although sa karon, gigamit pa ni sa 132, but of course, I will suggest that this will be eliminated. This is a basic part of organic chemistry topic. So you should be able to go through this before you go into the elective organic chemistry. But for the elective, dapat actually makover na to itong aromatic. Mataas na kayo ang chapter, so you will cover that one sa elective. Okay? So if you have no more question, and by the way, I'm doing overtime. It's a makeup class. So indicate your attendance. It's actually over na, ganina 7 p.m. Still haven't indicated your attendance, just tell me. And of course, since nahuman na ang chapter 11 and 12 now, I can upload on the problem sets for chapter 11 and 12, which you can work on for next week. Now our exam will be on the 24th. If I have already mentioned that one. So we'll be on Friday. Or if you want earlier, I can do that on Wednesday. But just to make sure that you have more time to study, then we'll move that on 24. And so next week, I will just have to record tomorrow on the aldehydes and ketones. So i-record na lang nako daan, and on ipa-play nako, ibutang nako sa LMS, and you can watch the aldehydes and ketones, which is chapter 13, I think. And just watch on your own, and then I will upload another problem set. If you look at the LMS, there is a problem set for radical reactions. Please, you can answer on the radical reactions. And hopefully, as many problem sets get upload, it will serve as a practice on your part. Most of the time I get it from Solomon's, but some others I may have get it some other references. So again, the key to organic chemistry is practice, practice, and practice. So it's always application. You couldn't answer reactions if you don't use pen and paper, if you don't use arrows. Okay, so that will be the only way for you to solve reactions for organic compounds. And most of the time, no, the problems will be like what is the product given the reactant and the reagent. Sometimes you need to plan the pathway for a particular desired product may happen. So there will be that part. So for the exam, of course, there will be mechanism. In chapter 10, it's radical reactions. So maybe I will include mechanism for that. Chapter 11 and 12, sumpay raman na siya, it's so alcohol. So some mechanisms can be balik-balik, no, from the previous chapters. And then, so 10, 11, 12, maura man na siya. So and some of the reactions, or most of the reactions actually, are balik-balik of the previous chapters. So I don't think it will be difficult for you because balik-balik lang siya. And the last chapter will be 13, but it is koan chapter, pinaka-last na siya nga chapter sa sharing aldehydes and ketones. So nucleophilic addition, nucleophilic aldehydes and ketones. So nucleophilic addition to the carbonyl compounds, chapter 16 of the Solomons. So we will be skipping aromatic compounds and aromatic compounds, and I will proceed with aldehydes and ketones instead of the aromatic compounds. Anyway, so I will discuss that first, and whatever chapters again that will not be covered in 131, you will cover that in 132. And there are only few chapters that needs to be covered in 132. Okay, so yeah, there is still amines, and there's a lot of chapters that will have to be covered in 132 actually. And the rest will be biochem. Okay, so those are the basics of organic chemistry. Actually, tsada na kung na-cover pa na to ang aromatic, but grabe na kayo ka-learner sa inyong part, no? So tama na ta dito, and do not forget to make it your attendance at chapter 10, 10 and 11 and 12 di ay, no? And sometimes I really wanted to practice on solving problems or organic chemistry. So I have to do problem sets. No, tagsa-tagsa na akong problem sets because there might be times no, dili niyo makawer tanan. But at least natunga na ako ang problem sets for every chapter. No, para ma-practice kin mo, and at least kung matunga na ko siya, kung di niyo mahulat to solve, there will be part of the problem sets you must solve. So for example, there are 10 problem sets. Hopefully you're able to submit all of those. If not, kung may 8 over 10, kana huli nga makapasar mo. And I would suggest as much as possible you submit your problem sets because it will affect your grade. But the overall one that really affects your grade is your exam. Okay, so please do make sure that you get right with your exam. As for the exam, let's just say we will do the face-to-face exam on the 24th. And if in any case that we can't do face-to-face for some reasons, then we will do the online. But bear in mind that the target is we do the face-to-face exam on the 24th. If you have no more questions, then that ends my session for today. And I hope that you learned something. And I'll give you space and time for you to work on the problem sets. Okay, so no more questions. I don't know, walahin naman nakasulod. Anyway, actually, same raman siya, no, balik-balik raman tong sa last session, this cut that I'm talking. Parehara siya, actually. It's just a retrosynthetic approach. And the reaction, you have already covered the basic concept, no, of Grignard reaction or reactions with carbonyl compounds. Okay, and yes, I will upload this, and please give me
Yes,
time.
ma'am.
Yes.
Wala ako ka-attendance sa LMS, ma'am.
So 2000 and should have been 16. That's right. Okay, I've moved it to 2000. So it's like 2 meetings for today. And yes, for the reactions of ethers, similar reactions, so I will upload also that one. And again, for the next week, I will just record just in case. Okay, that's all. If you have no more questions.